On the previous slides, we've looked at techniques for determining whether a relationship between x and y can be considered a function or not, and that is done at least graphically with the vertical line test. In addition, if we have a function, then there is a test known as the horizontal line test for determining whether or not we have a one-to-one function. But there are other types of functions that are out there that we will encounter along the way, and here are three examples of those. The first, y equals g of x, is the absolute value of x on the domain script A, which is the set of all x values between -2 and +2. Here is a graph. The domain runs from -2 to +2. The graph of y equals absolute value of x is V-shaped, and it maps to script B, which is the set of all values from 0 to 2. Well, if you look at this graph of the relationship between y and x, you have, from the vertical line test, you know that this is a function, and from the horizontal line test, you know that it is not one-to-one. Well, this particular function right here happens to be a 2-to-1 function, which is to say this part of the domain, namely from 0 to 2, maps to 0 to 2, and this part of the domain from -2 to 0 also maps to 0 to 2. So everywhere except for at the origin, this function right here is a 2-to-1 function. Here is a second example. Y is equal to g of x is the cosine of x on the domain x values from 0 to 4 pi. So in this particular case, if you put x on this axis and you run the y-axis from -1 to +1, here is 2 pi, and here is 4 pi. This will look something like this. It'll go down, do one cycle from 0 to 2 pi, and then a second cycle from 2 pi to 4 pi. Now, again, you can look at this particular graph and say, by the vertical line test, this is a function, y equals cosine of x. And furthermore, from the horizontal line test, you can conclude that this is not a one-to-one function. It turns out this is a 4-to-1 function, and what is meant by that is, if you look at the 4 pieces separated by the 3 dots that I've put on the graph here, this particular segment maps to script B, which is the set of all y from -1 to +1. And the same is true for this segment, and this segment. So with the exception of the points pi, 2 pi, and 3 pi, this is a 4-to-1 function. But not everything is going to be 2-to-1, 4-to-1, etc. You can also have the following situation. Y equals g of x is equal to x squared on the domain from -1 to 2. So here is the graph. This is x. Here is 1 and 2. Starts at -1. So script B in this case will be y values that range from 0 to 4. And this can be referred to as a piecewise many-to-one function. In other words, you can look at this little segment right here and say that is 1-to-1, and then this right here is also 1-to-1. So you could call this piecewise many-to-one. Might be legitimate to also call it piecewise 1-to-1 function if you're actually breaking it into these different segments. And this type of thinking is very important when applying the transformation technique, which we will get to later in the chapter.